Hello everybody and welcome to my presentation for my coursework 1, Machine Learning. We will be going through, today I'll be showing you and going through all the steps from 1 to 5, showing you what I've done, the outputs, specifically what each and every step does and what was required from the coursework in each bullet points. What we'll go through is step 1 to step 5 and basically go through the outputs, what was required, what I had to do, and what has to be done. Alright, let's go into it. My name is Ryan Kimbokimi and this is my presentation for today. For step 1, we had to mainly import the dataset. This was mainly important. This is the most crucial element of the coursework. Imported the dataset. We did this by using pandas data frame. This allowed me to not only to explore the first few rows, check for missing values, and confirm the data types. The goal of this step was to ensure and understand the structure of the data and prep for further analysis. As you can see, the df data frame is there, import pandas were imported, and of course the print. This page here, if I run it, here's here's my output for the first part of my coursework, step 1. Step 2 is my data visualization. What we had to do for this step is to output the output must and had to be a histogram. Step 2, what I had to do was I had to clean and visualize the data to check its distribution. I created a single histogram for one feature called X1 to show how the values were spread. This helped me to detect any skewness, outliers, or irregular patterns and could affect model training. Visualizing data at this stage helps ensure quality before modeling. As you can see, I've imported the dataset here, and as you can also see, here's the histogram, what I used for the histogram as highlighted here. I divided it 20 by 20. There's also, you can see here, 20 bins, and also the x-axis and the y-axis, the frequency, the labels, and so on and so forth. If I run this output, here we are. The output displays the histogram that has been presented through the code, the output of the data that we have selected, the output that we've gained, and what we have took from the data set. Step 3 is data preparation and splitting. In this method, we load the dataset from the CSV file. We select the input and output variables, split the data into 80% training and 20% testing for the fair model evaluation in the next step. This is mainly important because what we're doing here is mainly crucial for the preparation, and also is pivotal for step 4. Without doing step 3, step 4 doesn't really, you might as well forget step 4. Step 5, prepared the data modeling by separating the input features from X from the target variable Y. I then use a train split function. Train split function, where are you? Train split function right here is highlighted to divide the data into 80% for training and 20% for testing. This ensures that the models are trained on one portion of the data and tested on unseen data to measure how well they generalize. And as you can see, if successful, it will display the split into training and testing sets. So both will be displayed as I press here. Voila. As you can see, the training is basically successfully split into training and testing sets. Training samples 108 and testing samples 27. As you can see here, step 3 has been completed, the output has been completed, and now step 5. Not step 5, but step 4. Sorry. Step 4 is model training and visualization. In this set, we basically will train two different types of models: linear regression, decision tree regressor. One of them has to do with a straight line. One of them, how to differentiate. One of the graphs display a straight line, another a sort of curve that we will go through right now. So in this step, I trained two different regression models. First, I use a linear regression. As you can see, I use linear regression here, which assumed a straight line relationship between the input features and target variables. After training the model predicted the target variable to the test set, which I later compared to the actual values. Next, I trained a decision tree regressor. As you can also see here, the decision tree regressor, everything that's needed for the decision tree regressor. Unlike linear regression, a decision tree can handle non-linear relationships and capture more complex patterns. After training, it also generated predictions for the same test data. So if you can see, it creates points from the minimum and maximum, predicted y values, and you can see the straight line, and also the regressor, as you can see here, the non-linear curve. So the step 4, this is what we had to do for step 4, and if I run step 4, you will see right now for the linear regression, a straight line has been displayed, regressor, a sort of curve within the model. So two models have been displayed right here. Let's go to step 5 so we can get this. So let's go to step 5. Step 5 was model evaluation and comparison. Step 5 focused on evaluating, comparing both models. I calculated two main performance metrics. One of them was MSE, mean squared error. I believe I put this with mean squared error, which is here, which measures the average difference between actual and predicted values. Remember, lower is better. Lower is better accuracy, and higher R squared, better model fit, which tells us how much of the variation in the target variable is explained by the model. Higher is better. After calculating these metrics, I created a summary table showing results for both models. Then I visualized the comparison using a bar chart of R-squared scores, which made it easy to see which performed better. In my results, the model with a higher R-squared and lower MSE was identified as the better performer. See, it summarizes into a table, performance summary, the visualizer, and if I run this part, hopefully, yes, as you can see now, the linear regression, the decision tree, all the accurate information is there. You can see the statistics, and you can see here a graph. Models have been provided for you there. Optional enhancements to improve the depth of my analysis. I included two optional enhancements. First, the R-squared score bar chart allow for clear visual comparison between models. Second, I added a feature importance plot for the decision tree, which showed which input features had the most influence on predictions. These enhancements made my project more insightful and interpretive, aligning with the optional enhancement criteria from the assignment brief. For my Q&A, I answered two general questions. The first explained the optimal enhancements. I used the R-squared score bar chart and the feature importance visualization, and how they made my results clearer and more professional. The second question discussed why we split data into training sets. This is essential to prevent overfitting and to make sure the model performances evaluate fairly on unseen data. To conclude, this coursework demonstrated the complete machine learning process from data preparation and visualization to training, evaluation, and interpretation. I compared two regression models, learned how different algorithms perform under the same dataset, and added optimal enhancements to provide a detailed and meaningful analysis. Overall, the decision tree offered a stronger through feature importance, which linear regressors served as a good baseline for comparison. This project has helped me understand the importance of both accuracy, explainability, in machine learning models.